Hi students, today we are going to learn about the relations between zeros and coefficients of a polynomials. So let me learn the zeros and coefficients relations from the following example. So let us take a quadratic polynomial p of x is equal to 3x square plus 5x plus 2. So here we are going to find the zeros of this given polynomial. So you can, the zeros means the expression will become a zero, right? So let's considering the zeros means p of x will be the zero for any value of x. So let me consider this 3x square plus 5x plus 2 is equal to 0. Now we are going to factorize the given quadratic polynomial, right? We already know how to factorize, right? By splitting the middle term, we have to split the middle term according to the two condition. The splitted term must be, if we added, we have to get in a 5x, and also the multiples of the coefficient of x square and constant. What is the product of the coefficient of x square and constant? Is a 3 2s are 6. So product should be a 6 and sum should be a 5, right? It should satisfy the both the condition. Product should be a 6 and sum should be a 5. So we go with the product. We'll write all the factors of the 6. All the factors means 1 into 6, 3 into 2, or 2 into 3 is same, 6 into 1 is same. So with this, which will satisfy the sum 5, second one, right? So 3 and 2. So here the product of 3 and 2 is 6, sum of 3 and 2 is 5. So let me split the middle term with the 3 and 2. So here's 5x, so we'll write as a 3x plus 2x. So 3x square plus 3x plus 2x plus 2 is equal to 0, right? Now we will have a common factor in the first two terms and common factor in the last two terms, right? Here the common factor is 3x, right? Here also 3, the common is 3. X square, 1 of x is here, here x is here. So let me take a 3x by applying the distributive property. Here the x plus 1 plus here what is the common? 2, right? So 2 into x plus 1 is equal to 0. Now we got a two terms. In the two terms you can see that one common factor, x plus 1 is a common factor, right? By applying a distributive property, x plus 1 into the first term contains x plus 1, it's a common factor, and the remaining is 3x plus second term, the x plus 1 is the common factor, the remaining is 2, so is equal to 0. So if this expression have to be a 0, then either of this factor should be a 0, right? So let me consider x plus 1 is equal to 0. Then what is x value? X value is minus 1. Here let me consider 3x plus 2 is equal to 0. Then what is x value? So x is equal to minus 2 by 3. So we get a 2 zeros, right? This we obtain because it's from the final expression. It says either of this factor should be the 0. Then only we'll obtain a 0, right? So let me consider first term is the 0. Then it is a minus 1. If it is a second, so first factor is a 0, it is a minus 1. If it is a second factor is a 0, then x should be a minus 2 by 3, right? So let me take it as an alpha is equal to minus 1 and beta is equal to minus 2 by 3. Now I am going to add up the two things. Add the two things. That's given alpha plus beta. So what is alpha plus beta? Minus 1 plus minus 2 by 3, right? So by applying the LCM, the LCM is 3, so it will become a minus 3, so plus into minus is minus 2 by 3. So the value is minus 5 by 3, right? Let me go for the product. Alpha into beta is equal to minus 1 into minus 2 by 3. So minus into minus is plus, the value is 2 by 3. This is what the relations of zeros. The relation of 0 by adding the alpha and beta and multiplying the alpha into beta. Now they asked one more relation is coefficient. So let me consider this zeros with coefficient. The given question is, I will write an expression here again, 3x square plus 5x plus 2, right? Can you consider the minus 5 by 3, there is alpha plus beta. Can you compare with a given expression, given a polynomial quadratic polynomial? Yes, you can see the coefficient of x divided by the coefficient of x square, and negative is there. So minus 5 by 3 is just nothing, negative of b by a. Already we know this general form ax square plus bx plus c, right? Clear? So here b is a 5, so negative of b by a. Let me compare the alpha into beta, 2 by 3. So here the 2 is in the constant and 3 is in the a. So 2 by 3 we can write in the form of c divided by a, right? Yes, now we compare, right? So zeros, if you add two zeros, it will be equal to the minus b by a. If you multiples the two zeros, it will be equal to c by a. So remember that this is the relations of zeros and coefficients, right? So alpha and betas are the zeros, a, b, c are the coefficients of the given quadratic polynomial, right? Here we go for the problems. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficient. So we have to find the zeros of the given expressions and you have to verify the relations between zeros and coefficients. So we already saw the relation alpha plus beta is equal to minus b by a, alpha into beta is equal to c by a. We have to verify whether it's satisfying it or not. So find the zeros, it must be equal to 0, right? So 6x square minus, it's not in the order, a x square plus bx plus c. Just let me make it in an order. 7x minus 3 is equal to 0. Just rearrange it. The x square term is the first term and x term is the second term and constant in the third term. Now we have to factorize it, right? So here the product is 6 into minus 3. So minus 18. What about the sum? Sum should be the minus 7. So let me see all the factors of 18. It will become a minus. First we avoid the negative sign. 1 into 18 or 6 into 3, 9 into 2. Any other thing is there? No. Whether sum it will satisfy, sum it can be addition or subtraction. 18 and 1 it will never get 7. 6 and 3 also will never get, but 9 and 2 if you subtract we will get a 7, right? So it will satisfy the 9 and 2 and it should be negative 18 and sum also negative 7. So if you put a minus to the 2, 9 minus 2 will become a plus 7. So sum you have to obtain a minus 7. So I will put a negative for the 9. Minus 9 into 2 is minus 18. Minus 9 plus 2 is minus 7. So split the middle term with minus 9x plus 2x minus 3 equal to 0. The first two term, the common factor is 3, right? 3 and x is there. 3x. So already is there 2x minus 3 plus the next term, two term which is the common, there is no common, right? Then what we will take? We will take it as 1 as the common term. 2x minus 3 equal to 0. So now the two terms you obtain and 2x minus 3 is the common. So we can write it as an 2x minus 3 into the remaining is the 3x and the second term remaining is the 1, right? So to satisfy this equation, either one first product or the second product have to be the 0, right? So let me consider 2x minus 3 equal to 0 and 3x plus 1 is equal to 0. So what is the x value here? X is equal to 3 by 2, right? What is x value here? X is equal to minus 1 by 3. So this is an alpha, this we call it as an alpha, this we call it as beta. Now we are going to satisfy the relations alpha plus beta and alpha minus beta, right? So first we will find an alpha plus beta and alpha into beta, sorry. So alpha plus beta is equal to 3 by 2 plus minus 1 by 3. Right, here we have to take an LCM. LCM is the 6 and 6, so into multiple 3. So 9 plus negative 1 is that. So it is into 2 minus of 2 divided by 6. So the answer is 9. The plus into minus is minus 9 minus 2 is 7 by 6, right? What is alpha into beta? 3 by 2 into negative 1 by 3. 3 goes, the answer is minus 1 by 2. So it is the zeros, right? Now we are going to compare with the coefficients. So from the question we have to know what is the A and what is the B and what is the C. What is A here? A is a 6 and B is a -7, C is the -3. Right? Now we'll compare with an coefficient. The coefficient says the minus B by A, right? Minus B by A is what? Minus negative of -7 by A is 6. So minus into minus is 7 by 6. And next is C by A. C by A is a -3 by 6. And common factor is 3. We will get a -1 by 2. Whether alpha plus beta's value and minus B by A value is same? Yes. Alpha into beta and C by A values are same? Yes. So therefore alpha plus beta is equal to minus B by A. Alpha into beta is equal to C by A. Hence verified. Here we go for the next problem. 4u square plus 8u. Actually the constant term is missing, then we can add 0 and we can do by the usual method, or else without that method also we can do, which is very easy. I will tell you now. So just considering to find a 0, considering the given polynomial is equal to 0, and from here you can assume the common, right? U and 4 are the common. So let me take on 4u and the balance is u plus here 4 I took, u already is there, 2 is equal to 0, right? Clear? Now we can conclude either the first product have to be 0, next product have to be 0. Let me consider u is equal to 0, 4u is equal to 0, and the next is u plus 2 is equal to 0. If it is a 4u is equal to 0, then u is equal to 0, that is we call it as an alpha, and u plus 2 is equal to 0, then u have to be a -2, that we consider as a beta. Now we will verify the both. So alpha plus beta is equal to 0 plus -2 is a -2. Alpha into beta is equal to, what is alpha into beta? 0 into -2 is a 0. So next for the coefficient, what is the A? From the given A, the x square, here is a u square, coefficient of u square is a 4, and the B is equal to coefficient of u 8, and C is equal to no constant term, so it is a 0. So next is minus B by A, so it is a minus B value is 8 by 4, so it is a -2, we can cancel, and next is a C by A, C is a 0, 0 by 4, so 0 by 4 is a 0. So hence alpha plus beta is equal to minus B by A, values are same. Here the alpha into beta is equal to C by A. So alpha plus beta is equal to minus B by A, alpha into beta is equal to C by A, hence verified. Right? Here we go for the next problem. Find a quadratic polynomial each with the given numbers as a sum and the product of its zeros respectively. The sum and the product is given. So zeros of sum, that is alpha plus beta is given as a 1 by 4. That we know already with the coefficient it is a minus B by A, and alpha into beta is equal to -1, that we know C by A, right? It is given as sums and product respectively. The first one is a sum, the second one is the product. So comparing the both, we can find what is B, what is C, and what is C. So first we have to find the value of A. The both should be the same, right? Is it the same? No, but we can rewrite this -1 as to the 4, right? This we can write it as an -1 into 4 by 4, just an equivalent fraction. So it will become a -4 by 4. Now we can see that A is equal to 4 here, and again here A is equal to 4. So if it is not same, we can change to the equivalent fraction, and we have to find that both we have to make sure that both the A values are same. Okay, if it is not same, then rewrite the fractions and make it a same. So from here we can obtain A is equal to 4, and what is B? Here minus B is equal to 1, then B is equal to -1, and C is equal to here the -4. This you want to compare with here this term, right? Now we can we know the general form of the quadratic equation, right? That is ax square plus bx plus c. So what is a here? 4. So 4x square plus b is -1x plus -4. So this we can rewrite as 4x square minus x minus 4. This is the required quadratic polynomial. Here we go for the next problem. So the first one is the sum, alpha plus beta is equal to square root of 2, and second is the product, alpha into beta is equal to 1 by 3, right? And the a must be the same, that means denominator have to be same, right? Here the denominator is 3, it is not same, so let me multiple with the 3 by 3, so we'll get a 3 square root of 2 by 3. So we'll get now minus b by a, here is equal to c by a, so the a and a are same. So a is equal to 3, b is equal to negative b is equal to 3 square root of 2, that is, then b is equal to minus 3 square root of 2, and c is equal to 1, right? Then what is the general for quadratic polynomial? Ax square plus bx plus c. So a is 3x square plus b is a minus 3 square root of 2x plus c is 1. This we can take it as 3x square minus 3 square root of 2x plus 1. Clear? Here we go for the final example. So first term is the sum, and next second term is the product. So alpha plus beta is equal to 0, and second alpha into beta is equal to square root of 5. Here whether the denominator are same, yes, of course this we can write as a 0 by 1, this we can write as a square root of 5 by 1. So it is in a minus b by a form, it is in the c by a form, the a and a are same. So directly we apply in the form x square plus bx plus c. Here the a is a 1, so 1x square plus b is a 0, 0x plus c is a square root of 5. This we can write as an x square, the 0 term is no need to mention, so we'll just avoid square root of 5. Clear? Thank you.